Hey chemistry students, this week we're going to start off with a quick review of stoichiometry. Some of you have it, no problem, don't worry about it. It should be really easy. For those of you that were struggling with it before we went on break, hopefully this will give you a quick review and pick you up to the level you need to be at. Okay, let's start with an equation. Let's say we've got carbon sulfide, CS2, and we're going to oxidize that. In other words, we're going to join it up with oxygen, O2. That's going to form CO2, and it's going to form sulfur dioxide, SO2. Now, what exactly does this equation tell us? Well, first thing it tells us is that this is the smallest whole number ratio of the number of moles for each one of these. In other words, I've got 1 mole of carbon sulfide hooking up with 3 moles of oxygen, forming 1 mole of CO2 and 2 moles of sulfur dioxide. Well, what else can I figure out from this? I can look up the molar masses. Simple enough. You should all know that the molar mass of O2 is 32.00 grams per mole. In other words, oxygen 16.00 times 2 gives me 32. You might remember that CO2 is going to be 16 plus 16 plus 12.01, which would give me 44.01 grams per mole. Now, I've already looked up the values for carbon, 12.01. I know that off my head. Sulfur, 32.06. And I've calculated that SO2 has a molar mass of 64.06 grams per mole. And carbon sulfide has a molar mass of 76.13 grams per mole. All right, so now what can I figure out? Well, with this, I can figure the mass for each one of these. 1 mole of carbon sulfide is going to have a mass of 76.13 grams. So if I want to run this reaction exactly like it's written in my laboratory, I need to measure out 76.13 grams of carbon sulfide. I would need oxygen. Since it's 32 grams per mole and I've got 3 moles, that's going to give me 96 grams. I would need to have that much oxygen. I would produce 44.01 grams of CO2, and I would produce 64.06 times 2, which is 128.1 grams of sulfur dioxide. But realistically, I never work with exactly these amounts. So let's see how this works, and it's the same way, really. Let's see how this works with other numbers. Okay, so we got this problem from the textbook where we're running this in the lab, and we're starting with 150 grams of carbon sulfide. So I can start with this number using my molar masses. I can determine every other number in here. Now, I'm really interested in the masses, not so much the number of moles, but I'm going to step through it and show how we have to drop down to number of moles, move across, and then back up to get to where we're going. So, we start off with 150 grams of CS2. That's the number we're given. That's where we're always going to start. So the next step is we need to move down to the number of moles. How are we going to do that? Well, we want to get rid of grams, and we want to convert it to moles. And I know that 1 mole of CS2 has a mass of 76.13 grams. Now, if I stop right here, I end up with 150 over 76.13, which, doing the math on that, gives me 1.97031, yada, yada, yada. Don't care about the rest of those digits, because I'm going to round it off to 1.970 moles. Remember, I got rid of my grams, so I have moles of CS2. So I could put that in place, since I know what it is. 1.970. That's not where I want to be. I want to get over here. But again, I've got to take this little side trip. I don't want to start with this number. I want to start with 150 grams of CS2. If I were to take my rounded off number and start with that to make the next calculation, I would be introducing error into my problem. So I'm going to recreate what I just did. I want to go from grams to moles. 1 mole weighs 76.13 grams. Now the next step is I'm going from moles of one to moles of the other. So I want to get rid of my CS2, put it on the bottom. I want O2, put it on top. And now I bring the coefficients from my equation. That's a 1 and that's a 3. If I stop right here, my CS2 cancels, my grams cancel, I'm left with moles of O2. I have 450, 3 times 150, over 76.13. Doing the math there gives me 5.91094. Yada, yada, yada. Don't care about the rest of the digits. So that rounds off to 5.911 moles of O2. And I could put that number in, 5.911. But again, I'm not really interested in that. I want masses, because that's what I use in the lab. So instead of stopping at this point, I'm going to keep on going. 150 grams of CS2. Again, I have 1 mole, 76.13 grams. And you notice, even though I'm redoing these steps every time to show you what's going on, I'm still making sure I put in my units each time. If I don't put in my units, I can't be sure I'm setting my problem up correctly. So the last step is we're going from the number of moles of oxygen to the mass of oxygen. So I want to put moles on the bottom to get rid of them. I want to put grams on top because that's what I want. 1 mole of oxygen has a mass of 32 grams. Now, if I do the math at this point, I get 14400 multiplying across the top. 3 times 32 times 150. On the bottom, I still have nothing but ones, and that's 76.13. The math on this gives me 189.15013, yada, yada, yada. Don't care about the rest. Rounding it off, I get 189.2 grams of O2. And that is the answer I'm looking for up here. 189.2. So, how do I find these others? I'm going to take the same step. From here, go to moles, from moles to moles back up to grams. Same 3 steps each time. First conversion, second conversion, third conversion. So let's look at CO2. Again, I'm going to start off with 150 grams of CS2. I don't want to introduce any extra errors, anything I can avoid. Put it over 1. And again, I've got to go to moles. So 1 mole of CS2 weighs 76.13 grams. In fact, since I should be starting here every single time, I should end up with that same two terms at the start of every single calculation, because I'm trying to do the same step every time, convert to moles. So my next step is I want CS2 on the bottom to get rid of it. This time I'm going to CO2, so the CO2 will go on top. And my coefficients are 1 and 1. And if I stopped right here, I would have this number here. But I'm not going to do that. I'm going to go all the way to grams. So 1 mole of CO2 has a mass of 44.01 grams. Now at this point, I've got 6601.5 multiplying 150 times 4401. Still have 76.13 on the bottom because nothing else but 1's there. That gives me 86.713, 5, yada, yada, yada. Don't care about the rest of them. Rounding it off, I'm going to get 86.71 grams of CO2. 86.71 grams. Now, I said if I had stopped here, I could have gotten this number right here. So I'm just going to go ahead and do that to show you what would have happened. 150 grams of CS2, 1 mole, 76.13 grams, 1 CO2, 1 CS2. So if I stop right here, I get 150 divided by 76.13, which gives me 1.97031, which is 1.970 moles of CO2. 970. Now I want to point something out. You should have already noticed this, but 1 mole and 1 mole. In the formula, in my equation, I have the same number of moles of both. So whenever I do this, I should have the same number of moles of both. And I do. So I didn't even have to do this math. I could have, since knowing this number already, I could have just written the same number down right there. All right, last one. I'm going to go all the way over to SO2. Again, starting with 150 grams of CS2. Again, over 1. 1 mole. I'll try and get everything on this. Of CS2 has a mass of 76.13 grams. I'm going to go from CS2 and I'm going to go to SO2, and the coefficient there is 2. And the last step, I'm going to go from moles of SO2 to grams, and one mole weighs 64.06 grams. I do the math on that. I come up with 192.18 over 76.13. Calculate that out. I get 252.4366. That rounds off to 252.4 grams of SO2. So that is my answer up here, 252.4. Now, let's look at this real quick. 1.970 here, 1 to 2. So I should have twice as many moles of this. So if I pull out my calculator and I do 1.97031, yada, 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 if I come up with that number that I calculated right there, and multiply that times 2, I find out that I end up with 3.941 moles. Okay, I've switched my papers out, picking up right where I left off. If my problem tells me that this particular reaction has a 92% yield, then what I'm going to do is I'm going to take my theoretical yields right here and here. Theoretical yield times the percent yield equals the actual yield. So if I take 252.4 times 0.92, that's going to give me 232.2 grams. And if I take 86.71 grams times 0.92, that's expressing my percent as a decimal, gives me a yield of 79.78. And again, those numbers are rounded off. So, your task is going to be to do the same thing. I'm gonna put up the assignment for you on Remind. I will link it in the description down below, and I will make it available through email or however you need me to get it. Show your work, take a picture of it, and email it back to me, please. If you have any problems, email me. You can get a hold of me during my office hours and ask questions then. All right. Good luck. Get to work. Okay, so here's the homework for this week. Find the missing data, starting with 250 grams of iron 3 oxide. If you have any problems, you know how to get a hold of me. Thanks a lot, guys.